So question number 1 with our draw. I tried to pick a diagram that you could easily recreate on your piece of paper in front of you. So it says we can only move up and to the right and we're going from A to B. So drawing on this diagram is a great idea. That way I can keep track. So here's one, I will go all the way up and right. Here's another, up, right, up, right. A third, up, all the way over, up again. So that's by starting going up, I came up with 3 total moves. That's awesome. How about going the other way? So now I'm going to go to the right first. I've got all the way right, all the way up, right, up, and right all the way up to the right. That gives me a total of 6 different pads. All right, so what is the maximum number? Now let's draw this thing real quick. So I'm going to make this nice and big so I can see it. It says it's a cube, so I'm drawing my awesome cube. Very exciting. It says that each block is 2 spaces by 3 by 1. So my smaller cubes that need to fit into this larger cube are that big. So let's think about that for a second. If I've got cubes that are, this needs to be a total of 6 wide. So if my cubes are 2 by 3, that means I could fit 6 on this front piece here. So there's 6 on the front. And then as I go back, these are all a thickness of 1. So there's going to be 6 back here. 1, 2, 3, missed one. So there are 6 back there. So if I have 6 on the front and it goes 6 deep, that is 6 times 6, which is 36. Now there's a few different ways to come up with that one. I feel like drawing it is the easiest. Visualizing is okay. How many diagonals are there in a hexagon? So now we need a definition. A diagonal is connecting vertices. Now look at my crappy hexagon. Does it really matter? No. I made it nice and big, so when I draw my diagonals and connect vertices to one another, I can see what I'm doing. So here's 1, 2, 3. Keep track as we go along. 4, 5, 6. Now from this one, I already have 1, 7, 8. And I believe there should be one more. There it is. 9, total of 9. So drawing this was very important. There is an equation that works for this. It's n times n minus 3 all over 2, which would be 6 times 3 divided by 2, which is 9. But hey, what if I don't remember that formula? I can just draw it. All right, last one. In the triangle above, all of these are congruent little triangles. It says that DFH, and I would color that over, is 10. So let's find all the triangles that are that shape. Here's another. Here's another. Here's another. So every time I find 4, that's 10. So far I have 40 with the ones I have colored right now. Then I've got 1, 2, 3, 4 down here. Another 4, 1, 2, 3, 4. So there's 20 more for a total of 60. And then I've got one little lonely triangle down here. Now this little triangle has to be 10 divided by 4. Reason being, if 4 triangles make up 10 and I want only one triangle, 10 divided by 4 would give that to me. That's 2.5. So 60 plus 2.5 is 62.